In this second video detailing the model of the drum, we're going to look at three holes. The first hole is the counterboard hole on this end of the drum. We haven't yet talked about what function the counterboard plays, but it is very important when we start testing motors. So we're going to need this counterbore in the hole. And so that's the first thing we'll do. And then we'll use a plane to put in the first step of the hole on the top of this part, and then we'll add a tapped hole for 632 hardware that allows us to put a set screw into the shaft. And so those are the three features we will be looking at in this video. So the first thing I'm going to do is back up to the first feature. If I edit this feature, what I did to make this, if I was to completely restart, I pre-selected the face I want the hole in, and then I came to the features toolbar and chose a hole wizard. It's very important, in my opinion, that you pre-select the face, because if you don't do that, SolidWorks will often put in a 3D sketch for the position of your hole. 3D sketches are notoriously difficult to fully and properly define, so I avoid them unless it's absolutely necessary. In order to avoid it, I pre-select a surface for my hole wizard. So if you get to positions and it doesn't know where to sketch, let me show you what that looks like. If I just click hole wizard and I click positions, it's still looking for where to put the sketch. If I pre-select the face and put in a hole wizard, it already knows where I'm sketching. So that's a really important aspect of this hole wizard tool. So now I'll show you what I did to set up this hole. You could choose a counterbore and then just set custom properties, but SolidWorks has added a really convenient hole. It's called a legacy hole, and this allows me to set a custom type of hole. So a legacy hole here. I can change diameters. Oops. So for example, I can change the inner diameter of the hole. So this is a 3/8 through. I can change my counterbore diameter, and I can change my counterbore depth. It gave me an error because my depth for the through hole is set by this end condition. That's not editable unless I change this condition. So that's how I, and if you need it to be a counterbore, this is the type. So I can change it to a counterbore drill. So now I come to positions, and I would put it right on the center or origin of this sketch. And that should put in your counterbore hole. The next step I did was to make this plane. And let me turn on visibility so we can see it and edit feature. So this plane is, the first thing I selected was the top plane. So I selected this triangle to find my top plane. And it defaulted, I think, to parallel. And then my second reference, I chose the outer face. So I'll make this from scratch here to show you what it looks like. So I come to my features reference plane, and my first reference was the top plane, and my second reference was this circular feature. And if I change top plane to parallel, now I can sketch on the very top of this part. If it puts you on the bottom of the part for some reason, I think you just flip offset. There it is. And that would put top or bottom. And so that's how you would insert that plane. Checkmark puts it in. I already have it, so I didn't hit the checkmark. So then I hit my plane and I put a sketch. And, oh, actually, you know what? I could do that, but I actually just put a diameter hole. So in order to start my hole wizard, I selected my plane and clicked hole wizard, and this will allow me, if I put positions now, I'm sketching on plane 1. Okay, so again, I always pre-select where I want my hole wizard sketch to be. So that said, this feature is just a simple hole, and it's a number 27, which is bigger than the threads on 632 hardware. And that's all I really cared about. I do have one custom piece of information, and that's that at the bottom, I'd really like a 180-degree angle. If you see where it's measuring the angle, that's going to give me a flat bottom to this hole, which is going to make it easy to put the next hole in. All this first hole does is allow me to get to the bottom quarter to 3/8 of an inch of material where I want to put my threaded hole. This is just a clearance hole, really. So I put my position here. Let me go normal to that sketch. And this is where it came in handy to have the origin at the center. It allows me to put the set screw also at the center without having any additional constraints on this sketch. So that's my second hole. My third hole is in the very bottom of that sketch. Let me come to an ISO and turn my wireframe on. So the first hole gave me clearance, and the second hole gets me to the shaft. This second hole is a 632 tapped hole, and that is where the 632 set screw will screw into the shaft, holding the shaft and the pulley together. So let me turn shaded with edges back on. Once again, oh no, you know what? I turned off the plane, hide, and for this hole wizard, let me hide it again. I selected the bottom of the hole and chose hole wizard. And that's going to, when I get to positions, allow me to put my hole right at the bottom of the previous hole and concentric. So you pre-select, you have to kind of zoom and rotate. You pre-select the bottom of the face and choose hole wizard. So now I'll show you the features of that hole. This is a straight tap, and I chose 632, but I did change custom sizing. That's 116. If I restore default, 1065 is going to be a hard diameter to tap. It's a little bit too snug. So 116 is the standard diameter for 632 threaded holes. So what you would do is you'd come in with a 116 diameter drill bit to drill the hole, and then you'd come back through with a 632 tap to make the threads. My end condition, I did not choose through because through would go all the way through the part. I only want to get to the shaft. That's up to next. And I usually choose to take the thread out so I can see the actual diameter. Positions here, concentric with the original hole. And that's it. So that concludes these 3 hole features and this video.